Right. 5.2, ionic solids dissociate when dissolved in water. 5.2.1, define the term dissociation. To dissociate, it means they were together. Now they dissociate into ions. All right, so to dissociate is the process in which solid ionic crystals are broken up into ions when dissolved in water. So it's the process in which solid ionic crystals are broken up into ions when dissolved in water. All right.
So is it fine if you say the process by which ions the ionic substance is separated in the aqueous solution?
In aqueous solution, yeah, it's fine. It's correct. Aqueous, I think your water, you are covered with the water. But if you look at sugar, when you put sugar in the water, it does dissolve, but that's not dissociation because sugar dissolves, but salt dissociates into its ions. So there's a difference here. So dissociation is for ionic compounds, so that you've got your cations and your anions, and you're going to have free ions in solution. But sugar, there are no free ions in solution. So sugar dissolves, it does not dissociate. Okay, we'll move on to the next one. The next one says 5.2.2. Write down a balanced equation for the dissociation of ammonium carbonate, which is NH4, 2CO3 in water. All right, we've done this before. All right, so we're going to have, if I can, okay, you can just write this one here. Ammonium carbonate. Right. Right, ammonium carbonate, there you have it. So you're going to look at the formula for ammonium carbonate. You're given NH4, 2CO3. All right. Then you look at the charges. All right. Carbonate, we know. You need to know that one. Yeah, this one is 2 minus. It's 2 minus. All right. If this is 2 minus, your ammonia here, there are 2. So you're going to divide by 2, divided by 2 gives you 1. It means the charge here is a single charge. It has to be opposite of the charge that you have here. So if this one is negative, this one becomes positive. So positive times 2 makes it 2 plus, and the 2 minus, so your charges become balanced there. All right, so the charge on the ammonia is plus, ammonium ion is plus, and carbonate is 2 minus. Then you give it, you move on to the next one. You now separate these two, you dissociate the two. So the positive ions, that is your cation, you're going to be NH4 plus your CO3 2 minus. All right. Then you balance your equation. Ammonia NH4 is here, there are 2, so you put a 2 here to balance your equation. All right, then you put the states. Your ammonium carbonate, there's a S for solid. Then your ammonia here, you've got aqueous. Then plus you've got your also carbonate, there becomes aqueous because it's surrounded by water, it's in solution with the water. Right, so that's how you write the balanced equation for the dissociation of ammonium carbonate.
Sir.
Yes.
So is it fine if you see above the arrow, we put H2O to
Yeah,
show
you can
it's
put water here,
dissolving in water?
Yes, it shows that the solvent that you're using, you can put water here, it's fine.
Yes.
You can put water here, it's fine. Yeah, but you can leave it, you can put it, it's fine. Okay, we'll move on to the next one. Right. The next question, it says, the experiment set up below is used to compare the electrical conductivity of a calcium chloride solution. Calcium chloride, aqueous, and sodium chloride solution. Right? The concentration of each solution is 0.5 mole per cubic decimeter. Right? Then you're given the setup. You've got your battery, you've got your open switch, you've got your ammeter to measure the current, you've got 2 electrodes dipped into the solution. Then the calcium chloride is added drop by drop to water, and the ammeter reading is recorded after the addition of each drop. The procedure is then repeated with the sodium chloride aqueous. The results are shown in the table below. right? So you've got your number of drops of the solution. You've got your ammeter reading, calcium chloride, sodium chloride, right? Then each drop looks like it's a 0.18, right? So depending how many drops you're adding, then those numbers are changing. Right, 5.3.1 identified the dependent variable. Yesterday we spoke about dependent variable. We said what is a dependent variable? It's a variable that is measured during an experiment. What is an independent variable? It's a variable that is changed during an experiment. Controlled variable is the variable that that remains constant. Then we also have an investigative question. It's a question that is asking about the independent and dependent variable. The link between, you're asking a question between the independent and dependent variable. Your hypothesis is a possible answer to that investigative question. Right, right. So let's look at the dependent variable. Identify the dependent variable. So here in this experiment, what is being measured here? Huh? We are adding number of drops. And what are we measuring? We are measuring the ammeter reading. So your dependent variable is your ammeter reading or your conductivity. Right? That's what we are measuring. So your dependent variable, ammeter reading, or your conductivity. Remember when the question started here, we spoke about the experiment is set up below to compare electrical conductivity of a calcium chloride solution and a sodium chloride solution. So there are different substances that we want to determine their conductivity. Right, then we move on to the next one, independent variable. What is the independent variable? Is what we are changing here. What is it that we are changing? Bitumen. What are we changing here? Number of drops of solution. Are we together? Right.
Yes.
Here, what are we measuring? We are measuring the conductivity, or we are measuring the ammeter reading. Are we together? All right. Then B, what is our independent? Our independent, you can call it the type of compound. Because remember, we started with calcium chloride, then we use sodium. So we are changing the substance, the type of compound. Or by adding drops, changing the number of drops, we are changing the concentration of the ions present in that particular solution. So you can also say concentration of solutions. All right, we move on to the next one. 5.3.2, from the results, deduce the relationship between the ion concentration in a solution and its conductivity. So here you go back again here. As the number of drops are increasing, what is happening to the ammeter reading here? It's also increasing. So it means the higher the concentration, then the higher the conductivity. Or the more drops added, then the higher the meter reading. Right, so that's what we have. Okay, but they need a relationship between ion concentration and conductivity. So if you just say drops and ammeter reading, that's not exactly the correct answer, because they've guided you here. From the results, deduce the relationship between ion concentration. Ion concentration is the number of drops that we're adding, and conductivity is the ammeter reading that we are reading there. So the higher the ion concentration, the higher the conductivity. Right, next one, 5.3. Use balanced chemical equations to explain why calcium chloride is a stronger electrolyte than sodium chloride. This is a repetition, but it's being asked differently. We spoke about this, I think, yesterday in one of the questions above again. Right. So here, we're going to check your sodium chloride. You write the dissociation equation. All right, so you're going to have sodium disintegrating into Na plus Cl minus. How many ions do we have? We've got 2 ions. All right, so it forms 2 ions per mole of sodium chloride. Then you go to calcium chloride. Calcium chloride, what does it form? It forms Ca2 plus 2 Cl minus ions. How many ions are we forming here? We're forming 3 ions. Is that clear? All right, so which one is forming more ions per mole here? It's your calcium chloride. So the answer would be calcium chloride. So it says use balanced equation to explain why. So you can just explain that your calcium chloride ions forms 3 ions per mole as compared to sodium chloride that forms only 2 ions per mole. So as a result, your calcium chloride will have more ions, right, in solution as compared to sodium chloride. Clear?
So,
Yes.
so,
Yes.
so when it breaks down, when it goes like back to water, right? Then it's like before, like remember when you put like those two together, like to get like the product, right?
Yeah.
So it goes back to that form when it goes in water.
I'm not sure what you mean. Are we moving from the left to right or right to left?
Yeah, I'm meaning like this, but okay. I'm okay. In this case, I'm moving from left to right. Like when you normally like
When you move from left to right, it means you're starting with a solid that was not in water, then you drop it
okay,
in the water. Then that
okay,
particular substance is going to form ions. The ions are going to split into positive ones and negative ones. I'm not sure if I'm answering you what you're asking them.
yeah, okay, yeah. So I get it.
Yeah. Okay. Obviously, if you remove the water, then you're gonna move from the right. You're gonna move from the right to the left. So it means all the water is gone. Then it means the two are gonna attract one another. So they form one solid. Just like when you've got water dissolved in, if you've got salt dissolved in water. If you boil all the water away, it means the chloride, the calcium is now going to bond with your chloride, then it forms a solid. But if you move from left to right, the solid is going to dissociate into its ions, thereby forming free ions in the solution. That's why when you take salt, you connect salt, you connect a wire, it won't conduct electricity because there are no free ions, since the two charges are bonded. Right, but if you put it in solution, then your Na pluses and your Cl minus, now they are able to conduct electricity. Okay, right, we'll move on to the next one. Indicate the type of reaction represented by each of the following equations. Write down only precipitation, redox, or gas forming. Right, gas forming. Right, so what are we going to say here? We're going to say we need to check first our product. All right, so if you look at the first one, we've got zinc solid, and on this side here, we've got also copper solid. But we cannot just rush to say it is a precipitate. Because a precipitate, for it to form, there must be ion exchange taking place. How do you see that there's ion exchange? If I start with zinc, zinc must take the other ion here. Like here, zinc took sulfate, so we form zinc sulfate. But the copper here did not take any ion here because zinc didn't have another ion. So you need to be careful here. Having a solid here does not necessarily mean it's a precipitate. You have to verify whether it's if it's gas forming, if it's a redox or precipitation reaction. Obviously, this one, because there's no gas, there's no way this can be a gas forming reaction. So what do? You go and you write, let me just share this. Right, I think I have it somewhere here. Right, so basically what am I gonna say here? I'm gonna look at this, my zinc, let me rub this. Right, so we start. When you look at zinc, zinc is not bonded to anything, right? So we give it a charge of 0, oxidation number 0. Right, and this copper here is not bonded to anything, so we give it a 0. We want to see if the charges are going to change. Right, copper sulfate, sulfate we know it's 2 minus, SO4 is 2 minus. If this is 2 minus, it means copper, the ratio is 1:1. It means copper is 2 plus. right? Then we come to sulfate again, it's still 2 minus. And your zinc sulfate here, it's also a ratio 1:1. So it means the zinc is 2 plus. Now we check at the charges here, the oxidation number, did they change for these substances here? All right, let's check. We started with zinc, it was 0. On this side, zinc became 2 plus. So its oxidation number, did it increase or decrease? It increased. Whenever it increases, it means it's losing electrons. Right? We look at copper. Copper is 2 plus. Now it's a 0. Did the oxidation number increase or decrease? It decreased from 2 to 0. Whenever there's a decrease in oxidation number, it means it has gained electron. So what does that mean? It means zinc lost how many? By how many units did it change? It changed by 2. So it means zinc lost 2 electrons. And those 2 electrons were taken by copper, which gained them to form Cu. Are you following? So whenever their oxidation numbers are changing, that's a redox reaction. So this one becomes a redox reaction. Why? Because the oxidation numbers are changing. So you find your copper sulfate remains 2 minus. Your copper sulfate remains 2 minus. That's a spectator ion, right? So this reaction can still proceed without that. So you can just write it as zinc plus Cu2 plus. To give you Cu plus Zn2 plus. That's the net ionic equation without the spectator ions. So this is the reaction that is taking place, basically. All right? So your zinc loses to copper, and copper gains 2 electrons. That's your net ionic equation, this one. All right, so that one becomes a redox reaction. So 5.4.1, redox. We move on to 5.4.2. Zinc solid plus HCl to give you zinc chloride plus hydrogen. All right, so here we've got a gas forming here. There's a gas, all right? So you can say it's a gas forming. But my best answer here would be to check first if these high oxidation numbers or the charges here are not changing. Let's double check that one. So we're going to look at zinc not bonded, so I'll give it a 0 because it's not bonded to anything. And hydrogen is a diatomic. Anything that is diatomic bonded to itself, we also give it a 0. Right, then we come to hydrogen. Hydrogen, we know it's in group 1, so it's a plus. Chloride, we know it's in group 17, so it's a minus. Chloride, we know it's in group 17, so it's a minus. Right? There are 2, so it's going to be 2 minus. If these are 2 minus, it means your zinc becomes 2 plus. Right, let's take a look at the charges. Did they change? This one was, zinc was 0. Now it became a 2 plus. That's an increase in oxidation number. So it means zinc lost electrons. Then we look at the second one. Hydrogen was a +1. Now it becomes a 0. That's a decrease in oxidation number. So it means hydrogen gained electrons. Your chloride is a minus, and this side is a minus. It means chloride is a spectator ion. So this one, it's more of a redox reaction again. This is a redox reaction. Right. That's a redox reaction. But because since it's forming, most of the gas forming reactions, they're supposed to be ion exchange. Ion exchange is supposed to take place. Maybe because the zinc is taking the chloride, we can take it as an ion exchange because the zinc is going there. But it's more of a redox reaction. Right, fine. You check on the answers that I am going to send you. Here it says it's a gas forming simply because of that gas. But if someone says redox, it's also correct. But the best here would be a redox reaction, but we're also accepting the gas forming. because of the technicalities that you have in determining the oxidation numbers. So maybe because of that, we just give you the benefit of the gas formula. Clear? Right. Next one, 5.4.3. We check this one. Sodium is in group 1, so it's a plus. Carbonate is your 2 minus. Your barium is your 2 plus. How do I see that? Chloride is minus. They are 2. So this one becomes a 2 plus. Then sodium is a plus. Chloride is a minus. Barium, I know it's a 2 plus now. And your carbonate is a 2 minus. So what is going to happen here? Your sodium is going to take the chloride. That's why we've got sodium chloride here. And your carbonate is going to take, is going to go with the barium. That's why we've got barium carbonate here. All right. So there's ion exchange that is taking place. And you look at the states, aqueous, 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 and solid. And there was ion exchange that took place here. So this one becomes a precipitation reaction. So this one is a precipitation reaction. So this one is precipitation reaction. So for those three, you get redox, redox precipitation, or you can have redox gas precipitation. It's fine. Okay, we move on to the next question. Right, 5.5. Write down a balanced chemical equation for the following word equation. All right. So here you need to do your crisscross from first term. All right. Right. So we need to write using chemical symbols here, using chemical formulae to write this. So we start with the nitric acid. Nitric acid is your HNO3. Plus your copper. Copper is just a metal, so you're going to have your Cu. To give you, you've got copper nitrate. And the 2 in Roman numerals is telling you that Cu is 2 plus. And it's bonding to nitrate, which is NO3 minus. NO3 minus. So you're going to have a 2. You've got a 2. Okay, this 2 is not a nice 2 here. Okay. Right, so you've got your 2 positive and 1 negative. You do crisscross. So your formula becomes there are 2 nitrates and there's 1 copper. So your formula is going to be Cu, which is 1, open bracket. We need our nitrates here to be 2. So it's going to be NO3, NO3, right, with a 2 there. Plus, you've got your water. Formula for water is H2O. Plus your nitrogen dioxide. Nitrogen dioxide is your NO2, just like carbon dioxide. So it's your NO2, right? The question says we need to balance this, right? So let's balance it. Hydrogen here, we've got 1 on the left-hand side. On the right-hand side, we've got 2. So the hydrogens are not balanced. Nitrogen, we've got 1. Nitrogen here, we've got 2. So there's need to put a 2 here. So that the hydrogens are now 2, the nitrogens are now 2, here they are 2. Oxygen becomes 2 times 3, which makes it 6. And here we've got 2 times 3, which gives us 6, plus 1, which is 7, plus 2, which gives us 9. So it's not balanced. So our 2 here is going to be affected here. So the 2 here is not going to work here. Okay, so we need to remove that 2 because our oxygens are changing, right? So here we've got hydrogen, right? Then we, okay, let me just do it like this. Let me rub this. Right. So we start hydrogen here. I've got 1. Hydrogen is 1. And the hydrogen here, hydrogen there are 2. It's that one there and the 2. Then I've got nitrogen here. Nitrogen, I've got 1. And here nitrogen, I've got 2. And oxygen here, I've got 3. And here, oxygen, I've got 2 times 3, which is 6. 6 plus 1, 7. 7 plus 2 makes it 9. The oxygens are 9.
Mm.
Right, then I've got my copper. Copper this side, I've got 1. And the other side, copper, I've got 1. So copper is balanced. Nitrogen is not balanced. Hydrogen is not balanced. Oxygen is not balanced. How do we balance it?
So you have 2
So-
nitrogen on the reactant side.
Oh, okay.
No, it's a
Nitrogen,
3. 3.
it's 3, ne? Yeah, 3. Because 2 here and 1 there, yes. So nitrogen there are 3, yes. Right, how do we balance this? So we're going to start by looking at the nitrogens. Nitrogen, we've got 3, and here we've got 1. If we put a 3 here, our hydrogen is going as even numbers. So there's no way that will balance an odd number and number here. So if we can just start by looking at the hydrogen, we've got 2, here we've got 1, nitrogen we've got 3. All right, so there's no way we can balance this nitrogen that is here with an odd number. It has to be even. All right, so we can try by putting a 4 here.
Mm.
Because that's the number or even number after what? After 3. It cannot be 2. It has to be 4. Right? So if we make the hydrogens to be 4, right? What are we going to have here? Hydrogen, we have got 2, so it means we need to put a 2 here to make it 4. Right? Then your nitrogen are now 4, and your nitrogen here, you've got 2. You still have 2 plus 1, which is 3. All right, so what do we do here? Nitrogen, if we put a 2 here, our nitrogen becomes balanced because 2 here plus 2 here makes it 4. Right? So nitrogen is fine. Hydrogens, they are 4, they are fine. Let's check. Copper is 1, 1, so it's fine. Then we've got your oxygen. 4 times 3 gives us 12. So oxygen becomes 12. And this side here, you're going to have 2 times 3, which is 6. 6 plus 2, which is 8. 8 plus 2 times 2, which is 4. 8 plus 4 gives us 12. Then everything else becomes balanced. So you balance by putting a 4 here, putting a 2 on the water, and a 2 on the nitrogen dioxide. Okay, right. We move on. Right, so that's 5.5. Then we move on to question number 6. Chlorides and sulfates are found in water. These ions may be identified by insoluble substances they form in chemical reactions. Write down the correct term for the following description. The insoluble substance that forms when some solutions react. All right, insoluble substance that forms when that becomes your precipitate. All right, the substance will be called precipitation. Is it no precipitate? Is it precipitation or precipitate? It's a precipitate, right? Because it's a what? A precipitate is a noun, no? Right? So it becomes precipitate, not precipitation. Right, fine. Then we move on to the next one, 6.2. Complete the following reactions by filling in the missing reactant or product where applicable. So we look at the first one, 6.2.1, test for sulfate ions. You've got your Na2SO4, aqueous, plus something that is missing here that we need to add to give you barium sulfate plus sodium chloride. So what are you going to do? You check what is missing here. I've got sodium this side. I've got sulfate here. What I did not mention is your barium and your chloride. So the answer here becomes barium chloride. Do you see what I've done here? Okay, so you've got your barium chloride. So you check what you have on the left and what you have on the left, and what you do not have on the right, what you have on the left becomes what is missing here. So N, Na, Na, SO4, SO4, right? This side I've got barium and I've got chloride, so I've got barium chloride. So the answer is barium chloride. Then the next one says barium sulfate plus nitric acid. This one you need to go on the table here. When I add nitric acid to barium sulfate, there's no reaction. So there's no reaction. So the answer to this one becomes no reaction. Here there's no reaction. When I add the two, no reaction. So the answer here, barium chloride, BaCl2, and here you've got your no reaction. So your answer is going to be that. Right, step number 1, barium chloride. Step number 2, no reaction. Clear? Right. Move on to the next one. Test for chloride ions. Test for chloride ions. You've got your potassium chloride plus something here to give you AgCl plus KNO3. Once again, you check what you have on the left, what you don't have on the right. You've got K, you've got K here. You've got Cl, you've got Cl here. What you have on the right that is not on the left is your AgNO3, because I didn't mention this and this. So here you must add silver nitrate, AgNO3. Is that clear? Right. Next one, you've got your Ag silver chloride plus something here, no reaction. AgCl plus something here, no reaction. What is it that we must add here so that we don't have a reaction? Silver chloride. Right. Your answer becomes nitric acid. When you add nitric acid into that, silver chloride, no reaction. Once again, on your reactions here, if you've got a white precipitate, if you add nitric acid, no change. So it becomes silver chloride. Right. Okay, so that's what you have there. Then the last question. What is the color of the insoluble solid formed in step 1 of question 6.2.2? Step 1, what is the color of the insoluble solid formed in step 1 of 6.2.2? So we've got potassium chloride and we've got silver chloride. Silver chloride, if you check on our table, your chloride is a white precipitate. White precipitate. Is the bromide and the iodide that forms a pale yellow precipitate. So the answer becomes white precipitate for this one. So your answer, there's your answer, white precipitate. Right, so this is this brings us to the end of this consolidation exercise here. All right, tomorrow we're moving on. We're going to be learning moles, how to calculate moles. We're going to be looking at that from tomorrow. Right, any questions? Any questions? Right, so 10Y tomorrow, if I check my timetable, I'm going to see you, let me see what time. For physical science, I'm going to see you same time as today. Right, so we're going to have a lesson, but there are new times that are there. You must check on the WhatsApp group. Instead of starting at 7:30, we're going to be starting at 8. And the lessons are going to be 40 minutes long, not 45 as today. Right, so it's 40, 40, 40. So you start at 8 o'clock, then the first period ends at 8:40. Second one, there's going to be 3 minutes for just us to run around, because we have to move from one class to another one to connect and everything. So there's going to be maybe 3 minutes or so. Then we're going to start period 2, 8:43, 9:23. But school is still going to come out at 2 o'clock. So you guys check on the WhatsApp group for the times. So you check your timetable, then you follow that and you join. My joining codes are going to be the same, no change. So if it's physics, you still use the same joining codes. Just check on your timetable and see what time you're going to be joining that particular lesson. All right. So you guys enjoy the rest of your afternoon. I think we are left with 2 periods. I'm not sure what you do. What are you doing now? Right, you're going to have maths, I think, for the last 2.
Math.
Look for the code for joining maths, then you have maths. Right. Enjoy your day. See you tomorrow. Right. Yes. Yeah, you can sit here. Because we need the x to be in x, y to be in y. So here's the x, here's y. Okay. Right. Where are you staying at home? Yeah, well, sit down, sit down, sit down. Yeah, wait for it to come. Yes. Maybe these are not yet, I'm free now, but I'm going to have a lesson at the end, but I'm not going to have that lesson because there's things that I need to do. Yeah. Who paint the figure? When's the product? Right. Wait a minute. Wait a minute. Tell her.